go through the physical property of phenol. That is physical property of phenol. 2 to 3 points are there. One is pure phenol is a colorless, while it is colored, sometimes it is colored due to oxidation. That is the point 1. Pure phenol is colorless, but it is colored sometimes due to oxidation. The second point, that is it is sparingly soluble. Second point is it is sparingly, weakly soluble in water. However, it is easily soluble, clearly soluble in organic solvent. Third one is phenol, they have higher value of boiling point due to the presence of intermolecular hydrogen bonding. Next point is it is highly corrosive in nature. Phenol is highly corrosive in nature and produces a blister when it came in contact with our skin. These are the 4 points comes under physical property. I repeat again. One is it is colorless. Pure phenol is colorless. It is sparingly soluble in water, and it is next one is they have possess higher value of boiling point due to presence of intermolecular hydrogen bonding. And last one is it is highly corrosive in nature and produces a blister when came in contact with our skin. Next, switch over to the chemical property of phenol. Mark that chemical property. The chemical property of phenol comes under 3 categories. If we observe, it is the phenol. If you observe the phenol, then first chemical property due to the cleavage of OH bond. The second chemical property is due to the cleavage of COH bond. And third one due to the miscellaneous or due to the benzene nucleus. The 3 chemical properties are there. Let us discuss one by one. First chemical property is due to the cleavage of O-H bond. That is, under this category, first point is acidic nature of phenol. Let us discuss this one. First property is acidic nature of phenol. Point 1 is acidic nature of phenol. In class 11 already we cover what is known as acid. 3 theory or known theory are there. One is Arrhenius theory, one is Bronsted-Lowry theory, and one is Lewis theory. The oldest one, the Arrhenius theory, that is acid is defined as a substance when it is dissolved in molecule donate H plus ion. And according to Bronsted-Lowry theory, it is a species which gives a proton on ionization. Suppose if we observe that this applies this theory, it is a phenol when dissolved in water, then what is it formed? It is formed phenoxide ion plus it is known as phenoxide ion. It is known as phenol. So according to Bronsted-Lowry theory, when acid donate a proton resulting behind the what is left, that is known as conjugate base. That is known as conjugate base. So according to this theory, if acid donate a proton resulting behind what is left, that is known as conjugate base. But according to resonance says that everyone donate a proton. That does not mean that they are comes under acidic nature. According to this theory, no doubt that is donate a proton, but after donating a proton, what is left? That is conjugate base. That is, we have to judge its stability. If that conjugate base is stabilized by resonance, then only it is clear that the original structure behaves as an acid. Again, according to resonance, then we have to note down the resonating structure of phenol and also resonating structure of phenoxide ion. Then we observe that the phenoxide ion is much more stable than the phenol according to resonance. How? While writing the resonating structure of phenol, 5 structures are there. While writing the resonating structure of phenoxide ion, 5 structures are there. But we observe that one most important thing, here there is a charge separation. Positive charge and negative charge is there according to resonance. If in a molecule in a species involve charge separation, then it is less stable. But in case of phenoxide ion, there is no charge separation. So according to resonance, the conjugate base, that is phenoxide ion, is much more stable than the phenol. Hence, phenol behaves as an acid. As a result of which, the equilibrium according to Lee-Chatto principle shift forward, forming more amount of proton. Hence, phenol behaves as an acid. Let us draw the resonating structure of phenol and phenoxide ion and observe that how there is involved charge separation and how there is no charge separation is there. First, we write the resonating structure of a phenol. Mark that. Already know that how we write the resonating structure according to class 11. What do you observe? Mark that it is structure 1, structure 2, structure 3. Involvement of charge separation, positive, negative, positive, negative. Here also. From this structure, it is clear that involvement of charge separation is there. So, according to resonance, its stability decreases. Next, we go through the resonating structure of phenoxide ion and mark that how there is no charge separation. Observe that there is no charge separation is there, only negative charge is there. So from this structure it is observed that only negative charge is there, only negative charge there is no involvement of charge separation. Hence, from the above two resonating structure, it is clear that the conjugate base, that is phenoxide ion, is stabilized by resonance. It is more stable than phenol, so equilibrium shift forward, forming more amount of proton, which indicates the acidic nature of phenol. This acidic nature also verified by some equation. Let us discuss. First thing is there, if it is acid, we know how a substance, how a species become acid. The most favorable one is that it is treated with, react with active metal liberating hydrogen. So verify that when phenol treated with metal, what is it formed? Resulting the formation of sodium phenoxide, removal of hydrogen. So since it evolved hydrogen, it is clear that we have an acid. The second property is there, when it is treated with strong base, that is sodium hydroxide, acid base resulting the formation of salt and water. So from this equation it is verified that phenol behaves as an acid. Then we discuss about any factors are there which affect, which influence the acidic nature of phenol. Yes. According to inductive effect, two factors is there. One is electron withdrawing group, withdraw electron, that is known as a minus effect, and one is electron donating group, EDG, that is plus effect. Already over in class 11 under basic concept we know that the presence of electron withdrawing group, for example NO2, CN, X, halogen, etc., increases the acidic nature of phenol. Let us discuss one by one. It comes under what are the factors which affecting the acidic nature of phenol? Right? Factors affecting acidic nature of phenol. Point one is what we discuss. Presence of electron withdrawing group, presence of electron withdrawing group, minus effect. Suitable example is NO2, that is increases the acidic nature of phenol. So if we give an example by taking this one, then P-nitrophenol is stronger acid than phenol. It is named P-nitrophenol. Para-nitrophenol is stronger acid than phenol. Here it will behave as a minus sign. Point one. Point two is there. Higher is the number of minus I group, higher is the acidic nature. Let us discuss another one example. That is 2,4,6 trinitrophenol. 2,4,6 trinitrophenol is stronger acid than 2,4-dinitrophenol. 2,4-dinitrophenol, which is stronger than 2-nitrophenol. Again, which is stronger than phenol. What we observe here, that is acidic nature gradually decreases. Acidic nature gradually decreases. So what we observe here? Here we observe that 3 minus I group, that 2 minus I group, 1 minus I group, no group is there. So according to this concept, higher is the number of minus I group, higher is the acidic nature. Next we go through another point, that is the presence of electron donating group, that is a plus I group. According to this one, presence of plus I group decreases the acidic nature of phenol. If we apply this concept, we observe that. Let us select one example, that is very suitable examples are under this group is alkyl group. CS3, C2H5, ether group, methoxy, so many examples are there. Let us select CS3. So if according to this concept, presence of plus I group decreases the acidic nature. So if we compare the phenol and one CS3 group is there, it is known as a cresol, M-cresol, metacresol. So if you observe that there is a simple phenol and it is a plus I group is there, so it is acidic in nature, presence of plus I group, acidic nature decreases. So you say that phenol is stronger acid than M-cresol. Again, next point is there, whether it is a minus I group or plus I group, the presence of electron donating group as well as electron withdrawing group is more effective at para and ortho position in comparison to meta position. I repeat again, presence of electron withdrawing group increases acidic nature more effectively at para and ortho position in comparison to meta position. Let us discuss. It is increases effectively in case of minus I and also decreases acidic nature effectively in case of plus I. Let us discuss one example one by one. So if we go through example under minus I, that is NO2 group is there. Then it is known as P-nitrophenol, it is O-nitrophenol, it is M-nitrophenol, and it is phenol. Phenol is weakest as there is no minus I group there. It is, we can say that acidic nature gradually decreases. So it is minus I group according to this theory. Presence of electron withdrawing group, that is a minus I group, is more effective increasing acidic nature when it is present as para and ortho position in comparison to meta position. It is one example of minus I. Then we go through another example of plus I, that is CS3 group. What do we observe? What is the statement? The presence of EDG, electron donating group, decreases the acidic nature. Means it is ortho, meta, para. In each case decreases in comparison to phenol. So first is phenol. Second is, and according to the statement, most decreases at ortho and para. So second is meta. Next is para, last is, so it is known as phenol, it is M-cresol, it is P-cresol, and it is O-cresol. So among this, acidic nature decreases and phenol is highest in acidic nature. So it is a point one, presence of, I repeat again, presence of minus I increases the acidic nature. Presence of plus I decreases the acidic nature. Then presence of minor electron withdrawing group or electron donating group is more effective at para and ortho in comparison to meta position. Another one thing is there. That means some groups are there that is behave as minus I minus R. R means resonance, I means inductive, and one is plus I and plus R. While some cases are there, behave as minus I and plus R. According to inductive effect, it increases the acidic nature, and according to resonance effect, it decreases the acidic nature. So combinedly, if we observe that, then a resonance effect is more effective than inductive.